To determine whether a molecule is polar or not, you should first draw the three-dimensional structure of each molecule and then determine the shape. For water, it is V-shaped. For ammonia, it is trigonal pyramidal. For carbon dioxide, it is linear. Okay, and then for hydrogen chloride, it is also linear. Then you need to identify whether the bonds in the molecules are polar or not. So for OH, it is polar, and the two OH bonds can the polarity of the two OH bonds cannot cancel out each other, so it is polar. For ammonia, also the polar bonds, the polarities of three NH bonds cannot cancel out each other. So at last, you will have a dipole moment going upwards. So for CO2, although it has polar bonds, okay, but the two polar bonds cancel out each other. So the answer is C. So for question number 2, in which of the following substances is the strength of a hydrogen bond between two molecules is the strongest? Pentane does not have hydrogen bond. Methanol, you have the OH bond, so that it has a hydrogen bond. Ammonia, you have the NH bond. And then hydrogen fluoride, you have the HF bond. Well, in order to compare which one has the strongest hydrogen bond, then we need to compare the electronegativity of O, N, and F. The electronegativity of F is the largest, and then so the answer is D, which has the largest electronegativity, at which the atom attached to the hydrogen has the largest electronegativity, and that's why the hydrogen bond is the strongest. Question number 3, which of the following liquids will be defended by a charged word? That means we are asking whether the liquid is polar or not. Okay, so for choice 1 it is polar, CS2 is polar, but for hexane it is not polar. So that's why the answer is B. So for SF6, SF4, originally S has 6 electrons. Using 4 electrons to have the bonding, so at last you have 1 lone pair plus 4 bond pair. So for SiCl2, SiCl4, originally Si has 4 electrons, minus 4 electrons in the covalent bonding. It has low lone pair. So for CHCl3, again, originally has 4 electrons, and then use 4 electrons in bonding, so we have low lone pair. So that's why only SF4 has 5 electron pair surrounding it. So first trick here lies on the wording pivot 3 or below. That means pivot 1, 2, and 3. So actually the central atom of the non-octet molecules must be in pivot 3 or below must be incorrect, because for example, what we have discussed, PCl for example, selenium F6, selenium hexafluoride is non-octet structures, but then selenium is not in pivot 3. So for outermost shell electron shell of elements in pivot 3 or above can accommodate 8 or more electrons. This is true. For example, we have PCl5, SF6. These are we have these molecules, the central atom lying in pivot 3.